Good morning, Michael.
Good
How are
morning,
you
Matt.
for the second time this morning?
I'm great. I'm doing just great.
Good. So what's up for this time?
Well, I was thinking we should try to do something more connected with machine learning. There's a lot of information in machine learning and how it all works, but one of the key things is something called an activation function. And maybe you can tell us a little bit about that.
Sure, I just need a pen. So I'm not going to draw the neural nets in detail, but if you have just one single nerve cell and you've got an input coming in, just an input coming in, and what this does is it multiplies the input by a weight and adds a bias. Simple, one-dimensional. It looks much like y equals mx plus b. We can think of I like x. And then we get an output. And then we want to classify it. I'll put CLS for classification. Okay. And it has one or two possibilities. This is a very sketchy thing. It's not detailed math. It's either going to be of this class, it doesn't happen. In this class, it happens.
So 0 or 1 is kind of
0 or 1. So the way you could think of it is the desired output of this function, which is kind of a base function in neural net, something like this.
So a little step function. You go from 0 and jump up to 1.
Jump up to 1. But, you know, there's all kinds of funny things like these corners. They're not nice, so we'll get rid of the corners. Now, how quickly does it actually go to 0? Well, nothing goes abruptly, even with this. So what we have is we have a different function that starts at infinity, it's 1, and then it gradually comes down and then goes off to 0 at minus infinity, and it's called, this is x. What we see is sigma of x. Sigma is a easy function to write. I'll write it in a minute, and it goes from 1 here, and then at infinity, of course, it would go to 0, right? At infinity somewhere.
Okay.
So we can think of these lines, the x-axis out here, and y is equal to 1 as asymptotes. So let's see if we can apply some of what we learned to look at this function in a little more detail.
Okay. So I'm familiar with this sigmoid function, and we can write it out. It comes from the exponentials, and we like exponentials because they're fun to differentiate.
Oh, absolutely.
So what you do is you take one exponential, e to the x, and divide it by another exponential with 1 added to it. And you can see why you get this picture here. When x gets to be big, the exponentials are big, so this is like 1,000,000 over 1,000,001, which is very close to 1. And if x is a negative number, this could be very small, like 0.0001. This is divided by 1.00001, which is very close to 0. So that's kind of the picture that
So we can see when x goes to plus infinity, this becomes 1. Who cares about the number 1? And when x goes to minus infinity, we got 0 over 1, basically, which is 0. So there's the setup. Let's see what calculus can tell us.
Well, let's do something like this. One reason we didn't like this step function is it had an infinite slope there. So why don't we ask the question, this nicer function, what's the maximum slope that it has?
Let's have a look.
So I'm going to do this to make our calculations a little bit easier. I'll write it as the product, e to the x, times the reciprocal of 1 plus e to the x. That means I can compute the derivative using the chain rule.
And the product rule, yeah. So I guess the first thing to do is to do the product, break it in steps.
So this is the product of two things, one thing and another thing. I take the derivative of the first guy.
That's e to the x.
That's nice. E to the x, its derivative is e to the x. And then I multiply it by the second guy, 1 plus e to the x to the minus 1. Then I add to it the first guy, which is e to the x again.
And chain rule.
Chain rules. Okay.
Let's go.
So this guy is in front. We use the chain rule, so I'm going to put this in brackets. The minus 1
minus 1
comes out front.
Times 1 plus e to the x to the minus 2. And
don't forget.
Minus 2.
Minus 2. Yep, minus 2. And don't forget, we have to take the derivative of the inside part.
Which is, again, e to the x.
That's right, because the 1, it differentiates to 0, and then the e to the x comes back as e to the x. Now, we do a little bit of algebra. We notice there's a 1 plus e to the x to the minus 2. Here's to the minus 1. Quick little trick, we can just put
Everything
everything on the bottom. E to the x
squared.
squared. That covers this.
So we
This
got
guy here is e to the x. Because there are only a minus 1 there, I have to put a 1 plus e to the x so that this cancels with the 2.
to give you what you got started with.
And this other guy, I have e to the x. And I have
E to the x with a minus sign first, and e to the x all squared. And I think that takes care of it, does it?
It does. And then what happens? Well, you get e to the x squared, and here's the e to the x times e to the x squared. But that's a minus, so it cancels.
So we
I'm
get
left with
e to the x over 1 plus e to the x all squared. Now
Right.
we want the maximum slope.
We want the maximum slope. So that means we have to find the derivative of this guy and set that equal to 0.
Okay,
So we do the second derivative. And because we did all the work up here, I think we know kind of what's going to happen here. We're going to get an e to the x. Its derivative is e to the x multiplied by this other guy. I'm just going to write it this way. And then it's plus e to the x multiplied by, using the chain rule, I'm going to get a minus 2, 1 plus e to the x, minus 3, and of course there's an e to the x here.
wow, okay.
It's the same thing.
Same thing,
Same
it's
thing
same-
except the 2, 3, you know.
Yeah, that's about it.
And then we do the same trick, this thing we put on the bottom,
1 plus
1
e.
plus e to the x. This time it's cubed.
Now,
Here I'm going to get e to the x,
times
1 plus
e to the x. Same as what we did before in terms of the algebra, minus 2 e to the x squared.
e to the x squared. I can fix that. Here, e to the x squared.
And is that it?
Well, now what happens, this e to the x squared, it doesn't quite cancel because there's a 2. So what I get in the end is e to the x minus e to the x squared all over 1 plus e to the x cubed.
Okay, so now when is that 0?
Yeah, so we say, when is this equal to 0? Well, the bottom part doesn't matter, because this thing is always a positive number, so it's not going to matter. So the top part, we want e to the x minus e to the x squared equal to 0.
Yeah,
That's a little bit of algebra. So we're trying to solve e to the x minus e to the x squared is equal to 0.
so 1 e to the x cancels out. We get 1,
E to the x.
1 minus e to the x is equal to 0. So e to the x is 1.
This guy's never 0, so this guy has to be 0, right?
Yeah,
So 1 is equal to e to the x.
so x has to be 0.
0.
And we could
Aha,
have,
which we're going to see. It looks pretty steep here.
yeah.
Turns out that's the steepest
So when
place.
x is equal to 0, what's the value of sigma?
Okay.
It's e to the 0, which is 1, e to the 0, which is 1. 1 over 1 plus 1 is a half.
So that
There.
is sigma
At 0.
right here. And what's the value of the derivative?
It's maximal there, so it's 1 here and then 1 here, so that's 1 over 1 plus 1 squared, which is a quarter.
A quarter. So here is the slope. Slope equals a quarter.
And you could have kind of guessed that, and that what's interesting is if we go to the jump, usually in math, when you have jumps like this, you take the average just to the left and just to the right, and the average of 0 and 1 is, you add them together, divide by 2, is a half. So it all works out beautifully, and we use this over and over again in machine learning. So it's a great example. Thank you.
Thank you, Matt.